Hey everyone, and welcome to this explainer. I'm incredibly excited to have you here today because we're about to unpack one of the absolutely most vital architectural patterns in modern software engineering. If you've ever felt the sheer pain of an entangled, messy codebase, the kind where a single, tiny feature request means you're suddenly touching 10 different files, well, you are in exactly the right place. Today, we're mastering the observer design pattern in Go. We're going to see exactly how it takes us from fragile, tight coupling to a truly scalable, resilient architecture. Let's dive right in. Right off the bat, I want you to imagine a scenario. A user is on your e-commerce platform, they click buy, and they submit an order. Awesome, right? But what happens next? More importantly, what happens when an order completely fails just because the loyalty point service went down? This right here is the absolute nightmare of tight coupling. You've got an order service directly calling a whole bunch of downstream services. If that loyalty service crashes, suddenly your core business function, taking money for an order, fails just because someone couldn't get their bonus points. I really want you to feel the pain of that cascading failure. It's stressful, it literally costs your company money, and honestly, it's entirely avoidable. Let's walk through exactly why that kind of architecture is so incredibly fragile. When that order comes in, your naive order service does all this stuff sequentially. First, it tells the inventory to decrement stock. Second, it tells the email service to send a confirmation. Third, analytics records the event. Fourth, loyalty awards the points. And finally, fifth, the warehouse queues the pick and pack. In this setup, your order service has hard, concrete dependencies on 5 completely different systems. So what happens when your product manager walks over and says, hey, we need a 6th service to get notified about orders? Well, you have to open up the core order service code, modify it, test it, and deploy the whole thing again. Every single new consumer forces you to modify the producer. That wastes valuable engineering time and introduces massive risk. Okay, now for the aha decoupling moment. What if the order service didn't know about any of these downstream systems, like at all? What if it just shouted into the void, hey, an order happened, and whoever cares can simply listen? By doing this, we introduce a producer that knows absolutely nothing about its consumers. The system instantly becomes decoupled, highly scalable, and incredibly observable. It's a total game changer. So here's our agenda to get us there. 1, the core problem. 2, the radio analogy. 3, code walkthrough. 4, production async upgrade. And 5, pitfalls and scale. Let's start with section 1, the core problem. The crucial starting point is understanding exactly what the observer pattern, which is often called publish-subscribe or pub-sub, actually is. At its core, it defines a one-to-many dependency between objects. When one object, our publisher, changes state, all of its dependents, the observers, are automatically notified and updated. Mechanically speaking, it's actually really simple. The publisher just maintains a list, observers can dynamically register or deregister from that list, and when an event happens, the publisher simply loops through its list and calls a notify method on each one. That's the whole shebang. To really visualize this, think about a telephone call compared to a radio broadcast. A telephone call is tight coupling. It's direct, it's one-to-one, and the caller has to know exactly who the receiver is. I mean, you literally dial a specific number. If the receiver's phone is off, the call fails. Boom. Contrast that with a radio broadcast, which is honestly the perfect analogy for the observer pattern. A radio station is essentially just shouting into the void. It's a one-to-many transmission. That station transmits its signal without knowing who's buying a radio, who's tuning in, or who just turned the radio off. Any radio in range can just pick up the signal. Moving right along to section 2, the code walkthrough. Let's see how this actually looks under the hood. In Go, we start by defining some intentionally minimal interfaces. For the publisher interface, we really just need 3 core capabilities: AddObserver, RemoveObserver, and NotifyObservers. And for the observer interface, it basically only needs one thing: a method to react, something like onNotify, which receives a message. Now, in a textbook example like this, we might just pass a simple string as the message payload. But keep in mind, when you actually ship this in a production environment, that string payload would be a strongly typed event struct, packed with all the rich details of your domain event. Let's walk through a quick test-driven development scenario so you can see it in action. Look at this flow. We add 3 observers, observer 1, 2, and 3. Then, we intentionally remove observer 2. Finally, we trigger the publisher's notify method. Check out the output. Observer 1 receives the message, and observer 3 receives it. Observer 2 is completely absent. Why? Because we removed it. Now, in Go, the idiomatic way to handle that removal inside the publisher is using a neat little slice manipulation technique. You use append to essentially snip out the observer at index I. It's fast, it's clean, and most importantly, the publisher has absolutely zero knowledge of what observers 1 and 3 are actually doing with that message. All right, section 3, the production async upgrade. This is where things get really interesting. See, there's a pretty massive gap between textbook theory and production reality here. The textbook synchronous approach uses those basic interfaces and a blocking loop. It's simple, sure, but it has a fatal flaw when it comes to your service level objectives. If you loop over your observers synchronously and just one of those observers decides to make a really slow database call, it blocks the entire loop. That single slow subscriber degrades the response time of your whole publisher. That is exactly why the production approach is almost always asynchronous. We utilize Go's incredibly powerful concurrency model with channels to ensure non-blocking, concurrent execution. This right here is what you actually ship in production. Let's break down exactly how these Go primitives create a highly concurrent, safe publisher. First up, we use buffered channels. This prevents a slightly slow subscriber from immediately blocking the publisher. Second, we protect our subscriber list with an RWMutex. This allows multiple Go routines to publish concurrently while ensuring that subscribing or unsubscribing, which modifies that list, gets exclusive write access. Third, and honestly this is a massive pro tip, we use a select statement with a default case to create non-blocking sends. If a subscriber's channel buffer is completely full, that default case triggers, dropping the message rather than locking up the whole system. And finally, structured logging. When you hit that default case and drop an event, you absolutely must log it with context so you have observability into that back pressure. Now, while we're talking about architecture, I do want to give you a clear decision rule for when not to use this pattern. Let's compare Observer to the Mediator pattern. The Observer pattern is low complexity. The publisher fires, subscribers react, and there's no centralized routing logic. It's a simple one-to-many broadcast. But the Mediator pattern? It's quite different. A mediator actually knows about all the components and handles bidirectional orchestration and intelligent routing. It's much more complex. So your rule of thumb is this. Use Observer when you just want to broadcast events loudly and you don't care who listens. But use Mediator when you need intelligent routing, complex workflows, or strict coordination between your services. Okay, section 4, deadly failure mods. You're going to want to pay close attention to this one. These are real bugs that will absolutely take down a production system. Number 1 is the dreaded observer leak. This happens when subscribers register but they're never removed. Because the publisher holds a reference to the minute slice, the garbage collector can never clean them up. It's a massive memory leak that will eventually crash your service. The Go-specific fix to this, always use defer to immediately schedule an unsubscribe call right after you subscribe. Number 2 is the slow observer. We touched on this earlier, but if your loop is synchronous, a subscriber taking way too long is going to block the entire thread, halting all other notifications. You definitely feel the pain of that in production. The fix here is to dispatch each notification in its own Go routine, or, as we just discussed, use buffered channels with non-blocking sends. Do not let one bad actor take down your entire event bus. And finally, section 5, the massive scale reveal. Here's the secret you've actually been building on and using the observer pattern all along. At the code level, every single time you use React's useState, views reactivity, or even just add a simple click listener to the DOM, you're using the observer pattern. Actually, even Go's built-in channels are essentially a concurrent typed observer mechanism. But let's zoom way out to the system level. Apache Kafka, RabbitMQ, webhooks. When your service subscribes to GitHub push events, that's just the observer pattern running over HTTP. Kubernetes controllers, their entire watch and reconcile loop is literally the observer pattern functioning at a massive infrastructure level. It's everywhere. And that brings us to the core takeaway. Let this quote sink in. The observer pattern is how you build systems that can grow without coordination tax. Every new consumer is independent. Every new producer is unaware. That right there, that is the absolute foundation of truly scalable architecture. It is what makes it economically viable to add brand new features to your system without breaking what already works. So as we wrap up this explainer, I want to leave you with a somewhat provocative question to ponder. I want you to look at your own codebase right now. Where are you making fragile, tightly coupled telephone calls when you really should be broadcasting on the radio? Where can you completely decouple your producers from your consumers? Go find those hard dependencies and refactor them. Thank you so much for hanging out with me for this explainer, and happy coding.